Let's discuss on the example. Let's say for this example, gas is escaping from a spherical balloon at the rate of 2 meter cube per minute. How fast is the surface area shrinking when the radius is 12 meter? So first step, identify the information and the shape given here. The gas is escaping from a spherical balloon. So we have a spherical balloon. And then we know that the gas is coming up here. That is our understanding here. So the shape involving here is spherical at the rate of 2 meter cube. So meter cube is a unit for volume. So minute is a unit for time. Therefore, our variable we can see here will be dV dt, the changes of volume with respect to time. So the changes of volume respect to time, dV dt, it will be 2. Meter cube per minute. So why we put negative? Because your gas is escaping, your volume here is getting smaller and smaller. So that's why this is our first information, our variable dV dt, and our constant when the radius is 12. So this is our constant variable 12 cm, 12 meter. And what's the question asked? They asked how fast the surface area. So the question needed the rate of changes of surface area. So how fast? So surface area, we denoted it as S. Then we can move to second step. So that will be our first step. Identify the changes variable, the constant variable, the question needs, and what the shape involved here. So step 2, identify the chain rule. So look at the question that we asked here. They want dx dt. To form our chain rule, we start with dx and with dt. And then look at the information that we have is v. So of course, we will relate this x to v. So dx dv times dv dt, where we can notice that dv dt is given. So it will help in our chain rule. So for this part, dv dt is given. So we no need to change. We obtain it from the questions. So look at the derivative we need to find here. So now we focus the derivative here, ds dv. From ds dv means we need the equation s in terms of v, which is surface area in terms of volume. But as we know, surface area formula is equals to 4 pi r squared. So s is in terms of r, s is not in terms of v. So therefore means our chain rule here, we have to modify it according to our equation. So ds dt will be more suitable to use the chain rule as ds respect to r, then dr respect to v, and then come back to v dv dt. So this is the more suitable chain rule that we obtain. So equation needed here will be S in terms of R, surface area in terms of R, and V in terms of R. So therefore, we go for step number 3. Surface area in terms of R, volume in terms of R. So what we need to find is differentiate surface area with respect to R. But for this V and R, we are going to differentiate volume respect to R, then we inverse it to get dr dv. So therefore, for surface area, when we differentiate it, power turun depan, power tolak 1. So we are differentiate S with respect to R. Here we have power turun depan 8, power tolak 1 is R power 1. Meanwhile, for V, we differentiate respect to R, so power turun depan we get 4, and then power tolak 1 we get R squared. Then look at the chain rule. What we need is dr with dv, and we already get dv dr, so we're going to inverse it. So 1 over 4 pi r squared, so that we can get dr dv. Then notice that we done the SDR, we done our dRdV, and dV/dt is given in the questions. Lastly, questions step number 4. We're going to substitute all the differential equation and all the information back into the chain rule here. So our chain rule we substitute where dV/dt from the question, this is the derivative that we found, and r is the constant variable. So substitute back into the chain rule. And together with the r. So r is a constant 12, means this position r will be substituted by 12. Lastly, we just press calculator and see what's the value. So we can see this is negative 1/3 meter square per minute. Why meter square per minute? Because surface area unit is meter square. Meanwhile, the time variable here we use unit of minute. Thus, when we look at our derivative here, when it is negative, means the rate of the surface area is decreasing. So the surface area also shrinking at the rate of 1/3. So when I say already shrinking, means already represent the rate of change is decreasing. So when we have ds dt equals to negative, our sentence can be explained by shrinking by 1/3. No more negative. The negative already illustrated in the sentence means shrinking here, decreasing here.